Good afternoon. I'm going to do what I apologize for being the Evelyn Wood speed reader version of neuroscience and biophilic design. There are spaces that we look at and we just sort of love, and we know intuitively that these seem to be good places for people, and we read them as being beautiful. They're places that we go to be restored, to be inspired, to be calmed, and a variety of conditions. And so this is sort of taking the elements of those things that we intuitively know and trying to give some science to them. And so that's the basis of the conversation about biophilia. The term comes from the social psychologist Erich Fromm, literally love of nature, but it really didn't get any currency until E.O. Wilson wrote his book in 1984, biophilia. One of the early pieces of science that most people have experienced when they get into this is one of the first things they encounter is Roger Ulrich's study of patients recovering from a specific surgery. And they matched all the patients in this hospital by demographic and even the paint color of the room, and the remaining variable that they had left was what was the view out of the window. Half of the patients had a view to the brick wall, and the other half of the patients had a view to a clump of trees and shrubs. Not some incredible, fabulous landscape, just trees and shrubs. The patients who saw the brick wall took on average 8.3 days to recover. The patients who saw the trees and shrubs took on average 7.4 days to recover, had usually about half the number of nursing calls, and took half the number of painkillers. And so this is one of the early pieces of evidence-based design, connection to nature in a hospital setting, and help lead to the whole Healing Gardens movement. And you see things as a result of it, like this hospital that opened last year in Singapore, Ning Tong Phu, designed by CPG architects and HOK. It's day-lit, naturally ventilated public hospital. There are 4 to 6 beds in each ward, and every bed has, next to the head of the bed, a window and a view to a sky garden and a 20-plus story tower. But sometimes we can't bring living nature into the situation, and so there was work that Ulrich and others have done in Sweden on looking at cardiac recovery, giving people a picture of nature or just a blank sheet of paper. And they were looking at changes in heart rate, blood pressure, and recovery time. And those patients who had of that picture of nature had much better outcomes. That led Peter Kahn and his team at the University of Washington to ask, is simulated nature enough? And so in this 2-year experiment, they gave people a stressor, and the recoverer is either staring at a wall of curtains, some of the curtains open and seeing a view out the window to these trees, fountain flowers on the UW campus, or, and actually in this case, some of the curtains open and a high-definition flat-screen television of the exact same dimensions as the window and broadcast live on the flat-screen television the view that you would have had out the window. Staring at the curtains was not particularly helpful. The psychological response to the flat-screen television and the real view was pretty much the same. The physiological response, however, was different. Seeing the simulated view lowered blood pressure and heart rate, but not as much as seeing the real view. So we were doing work with Peter, with another of our clients, and we asked Peter why, and he said, we don't know. That wasn't the answer we wanted, so we went and talked to some of the optical scientists that we work with, who said, that's a simple answer. Parallax. With 2 eyes, what we see 3-dimensionally changes. And apparently, the brain responds differently to that. So the folks who did some of the early work on biophilia and visual processing are Irving Biederman and Ed Vessel, at USC. And they were looking at where in the visual cortex different images get processed. And in particular, they were looking at the triggering of mu receptors and the opioid response to different images. And what they found was these different images all got processed in different parts of the visual cortex. As you move through the progression, they moved down sort of the funnel of the visual cortex to the larger and larger areas of visual cortex, the smallest being starting with the gray wall, and then the pile of bricks, then the street scene, and then finally the Japanese garden. The persistence of the effect was also interesting. Each time someone looked at the first three images, it got less and less interesting and triggered a smaller and smaller response. That was not the case when seeing the scene of nature. The interest in that persisted. So we're also getting interested in sort of breaking down components of nature, and particularly looking at things that occur frequently in nature, i.e. fractals, golden mean, Fibonacci sequence, and seeing how people respond to that. And particularly when we find that there are self-repeating patterns that are in motion, like waves or flames in a fireplace, we're pretty fascinated by that. I mean, there's no rational reason why I should stare at a fire for hours, but we find it highly, highly pleasurable. We're also learning that there are some interesting effects in combining senses and responses to senses. In particular, one of the more intriguing pieces is the discovery that where a sound gets processed in the brain may be tied to what we're physically seeing. And so this comes from this study, which came from the insight that sometimes the sound of waves and the sound of traffic are very, very similar. And so in this experiment, they averaged the sound and showed people either the image of the traffic or the image of the waves, and that same sound got processed in different places. Now, in particular, when you then tie that to water, that could be really beneficial. As office settings are getting more and more noisy and more problematic, there are a number of teams who are looking now at the psychoacoustics. So how many architects in here got trained in acoustics? Right? So that's really important. How the sound reverberates around the space, bounces around, and gets to our ear. But every sound in the space is always coming to our ear in real time. Every conversation. When we were out in that lunchroom, every conversation in that room was coming to our ear. How many of them were you hearing? Basically about 1.6. So the question is, what's that filtering mechanism? And so that's the entire field now of psychoacoustics. There are a couple teams who are really specialized in this, one at Fraunhofer Institute in Stuttgart and another in the UK. And one of the things they have discovered is that by far the most effective masking sound you could possibly do in an office is the sound of flowing water as if it was a small stream or a little waterfall. Now, if I was using water just purely from acoustic masking standpoint, large volume of water pouring into a basin is far more effective for acoustic masking, but not in our brain response. We will select that sound of that small waterfall or that small stream. Now that seems to have an evolutionary basis in that in most environments, the cleanest drinking water is going to be from that source, and it would make sense, therefore, that we would be attuned to that sound. Taking another track and looking at how sort of cognitive performance is impacted by experiences of nature. This was a study in Barcelona looking at 2,600 children. And those children, they looked at green area coverage, which actually was tree canopy around the home, around the commute, and around the schoolyard. And they found that those children, separate from demographic, that had the highest level of tree canopy in their schoolyards had a distinctly higher level of cognitive gain over the course of the school year. So now let's translate that inside. And so this is an experiment that actually physically started last week in Baltimore. And is Sergey here? This is a collaborative that we're part of along with architect Jim Dieterman in Baltimore, Morgan State University, and Sergey Getstein from here, to study what happens when we take a classroom in a STEM academy in the inner city of Baltimore, which is not particularly biophilic now, and add some components to it. And there's a second classroom. These are both math classrooms of the same grade, facing the same view, with the same teachers having taught in those classrooms for multiple years. And we're going to study the outcomes for the children this year, compare them to prior years against the two classrooms, and the outcomes for the teachers themselves. And so this actually got underway this last week. In the discussion of biophilia, in particular, you will see the work and the concept of attention restoration theory. Now, it's not a new idea. Here we have Olmsted talking about it in 1865, but the folks who really gave it its main definition were Kaplan and Kaplan. And the question has been, how much exposure to nature do you need to get the brain to quiet down and have that experience of cognitive restoration? And this was a really nice piece of work done in fMRI by a team at the University of Melbourne in Australia, who discovered that staring at the asphalt was not so much helpful, but in the recovery, staring at the same rooftop image rendered with flowers took about 40 seconds. So there are many different ways we can bring nature into the built environment. Plants and water are nice, but there are just a very small portion of the ways of addressing that. We find they fall into a different piles of categories, and within that we've developed a pattern language that's a pattern language that's a little different than the traditional pattern language, and then it's a pattern language of experiences. Maybe the most important lesson out of that, though, in looking at this work in application, which has been supported by Google for us in the last 8 years in developing metrics for their buildings and campuses, is that different experiences of nature elicit different outcomes. And so you'll see in one of our publications, you will see this chart, and the way it's being used by some designers now is actually asking what's the outcome I'm hoping to achieve in this space, and then filtering the use of the patterns to help support that. Finally, we're doing some observational work, and that is looking at how do people actually respond to biophilic design. It's one thing to implement, the other is actually to take the next step. And so this is part of a larger study of biophilia and hotel design, and we were looking at, does biophilia change the way that people use and use patterns in hotel lobbies? And so we looked at a number of hotels in Midtown Manhattan, roughly the same price point and room count. Half of them were just conventional lobbies and half had a lot of biophilic design measures. And we saw a 36% increase in the number of active and passive users in those lobbies that had strong biophilic design measures. Now, for the hotels, this is a home run because it means now that people are probably buying a coffee or buying a glass of wine or getting some food. They're hanging out, talking with their friends, creating a social buzz in the lobby and increasing the revenue of the hotel without selling another room. We want to take this a step further, though, and so in partnership with the Cloud Lab at Columbia University's Graduate School of Architecture, we are hoping to now do an exercise in neural cartography, and that is put emotive headsets on folks with a nice hack that the Cloud Lab guys have done that allows us to geo-track the outcome of these headsets and translate it into colored pixels on a map. And depending on which brain state folks are in, which wave pattern we are seeing, the pixel on the map will change colors. And we'll take hopefully about 40 people through this experience to get 26 or 27 good data sets, and then layer them on top of each other to see if the space is indeed inducing the response we're hoping for. If you want to read more about this work, We have a bunch of publications you can download for free off our website, including case studies and other materials. Thank you. And so you don't have to memorize the 14 patterns. I've got cards here that have got them and the references on it.
Okay, great. We have time for one question. I see on the opposite side of the room. Yes. Well, she raised her hand first. Over there. Maybe two.